Hello! In this video, the continuation of part 1 or quantum ledger database overview, we will walk through the software diagram and all the steps required to create tables, verify them, and export our journals to an S3 bucket using an API for Python. If you're wondering what the heck QLDB is, please make sure to visit part 1 before watching this. First, let's review the software diagram. So the first thing we need to do is create a simple storage service bucket, which is where we will send our journal exports. Second, we want to create a role via IAM that will allow our client later on to export the journals via QLDB to S3. This role needs to reference the S3 bucket that we create, so the bucket will allow it to insert the journal. Third, we will do the bulk of the work in QLDB. Here, we will create the ledger and its corresponding tables, acquire the digest or hashed journal, query the metadata that we will verify, and validate the API request for a journal export. Fourth, we will acquire the digest and send out the command to export the journal via Bodo3, which hosts an array of Python APIs for various AWS services. Finally, we will confirm that everything is in order by looking at the journal inside our buckets. So our first step is to create the simple storage service bucket. So let's get started. Now that the blood is clearly flowing through your veins, let's get started. In the AWS Management Console, we first have to select the S3 service. Now I have it already selected, but let's go ahead and type for the scalable storage in the cloud. Then we'll get started on creating the bucket, which is where we will store the journal or records of changes made to the tables we will later create. We will click on Create Bucket. Shocking, I know. Next, we will create a distinct name for our bucket. In this case, we will call it QLDB Journal X Test. We will click on Next. In this example, we won't worry about versioning or other options. We're going to keep it simple. For simplicity in this example, we will unblock public access by clicking this box right over here. The reason for this is that we need to be able to upload files to the bucket from a client computer. We will click Next, Review, and create the bucket. And voila! There is one piece of our project. Creating a bucket is life-changing, I know, but we cannot do too much with QLDB if we leave it at that. Next, we need to create a policy and role that will allow us to interact with QLDB and the bucket. For those of you who like dark places and expensive drinks, if QLDB and S3 are the bouncers, the role and policy that we create in IAM will put us on the list and allow us to interact with both services. Back in the AWS console, we're going to be looking for the IAM service. With this service, we are going to create both a role and a policy. We'll get started with the policy. We first create a policy and then attach it to a role. In this case, we're going to create a policy with JSON script. First, we'll create on Create Policy, and then we will go into the tab of JSON. Within here, we are going to use a JavaScript object notation script to be able to write into or export the journal into the particular bucket. This is where we denote the bucket that we are actually using, and it's one of the most important fields that we can actually insert here because it will allow us to write the exports into the bucket. Following that piece, we will click on Review Policy, and we will call this particular policy QLDB write 3. And with that, we'll create the policy. Our last part in this IAM Odyssey involves attaching the policy that we created to a role. From the policy section, we'll click on roles, and then click on Create Roles. The reason why we can't stop at policies is that QLDB requires a rule, not a policy in the console and API. Thus, we need to configure one. We'll search for the service that we want to use, QLDB. Next, we will find our gloriously crafted QLDB write 3 in filter policies, customer manage, since we created it. We'll click on it here, and then we'll go into tags. Tags are pretty cool, but I want to get you out of the door pretty quickly, so we won't tag this. Finally, we will review and create the role. In this case, we'll call it QLDB journal test. And that wraps it up for IAM. Now we can finally get into QLDB. QLDB is where the magic is going to happen. Here we will do the following. Create the ledger. For simplicity, you can think of it as a database where we will house the tables. We will also create the tables using Particle, an Amazon open language that is designed to work with both SQL and NoSQL databases, and Ion, which is a format related to JSON. Then we'll also retrieve the digest, which is the fingerprint of the journal or a hashed journal. This we're going to need for verification. And finally, we're going to run the metadata query to retrieve the changes made to the database. This is again going to be used for verification. Verification entails making sure that everything has integrity, that the databases have not been maliciously altered, and that they're still located where they were originally stored. So let's get started. First things first, we'll go into QLDB and create a ledger. As we mentioned, the ledger will host the tables that we will soon create. We'll click on Create Ledger, and we are going to get extremely creative and call this database something like test. We'll ignore the tags for the time being, and we'll create the ledger. Next, we will create the tables. Because we're party people, we are going to use Particle to create 3 tables for our test ledger. However, because I'm sure you can think of a million better things to do than watching this video, we will only go through one table. First, we'll click on Query Editor. Now, here's where we'll actually insert our code. You'll see that our ledger is selected right over here in test, and that we do not have any tables. This is where Particle is going to come into play. Keep in mind that Particle is an open Amazon developed language that is designed with both SQL and NoSQL tables in mind. First, we'll create a table called vehicle, and then we'll click run. And as you can see right over here from the table ID, it was successful. For those of you who are SQL savvy, you may ask, McGurd, he is not defining columns or data types. Particle doesn't require you to. We'll also create an index, and we'll review Amazon Ion after creating this particular index. So same syntax, we'll just basically create that index on that table. We'll run it. We see that it is successful based on that table ID, and then within that table, or within the query editor, we'll insert the following values. And these are those particular values. Now, you'll see that it looks a little bit weird, right? We have these 2 less than signs. This is part of Amazon Ion and the format in and of itself. It is related to JavaScript object notation, and it functions with Particle, meaning that if you're using, for example, other SQL dialects within Query Editor, they may not work as well. We'll run it, and we see that it is processed right here. And just to verify, what we'll do is we'll do a simple select query to make sure that we can actually view the data. And voila, we see that the data is filled here with all of our fictitious data. So to save you guys some patience, I created 2 additional tables, contact and customer. Now we're ready to pull the metadata for verification purposes. What metadata? We'll go over that shortly. So this is the code that we'll use to run the metadata. The ID here corresponds to the change made to the particular table. The block address corresponds to the block of the change made. Now, this all pertains to a thing called a journal. And the journal basically captures the changes made to a particular table. Changes made to a particular table could be grouped together in a block. Think a blockchain. In the from statement within row 2, the name of the table will go after the QL committed. This is how we know that we are pulling the metadata ID as well as the block address from the vehicle table. Running this, we see right over here the ID of the particular change as well as the block address. Here we can see that many of the changes are actually combined together in one block. We'll get the first one right over here, which we'll use for verification, and verification entails making sure that the integrity of the table is intact, that is, that it has not been altered maliciously, and that it is still in the same location where we originally created it. Now we have one piece of the puzzle, that is, we have the metadata. In order to verify, we need 2 things, that is the metadata as well as the digest. In order to verify, we need to have the digest, which will act as the fingerprint to verify whether our sample, in this case the metadata, is valid. What we'll do is we'll click on ledgers. That's how we got here. We'll click on the particular ledger that we want the digest for, and then we will click on Get Digest. Once we click on that, we'll get this particular screen. We'll save the digest, and it will save in ion.txt format. Save it somewhere safe, and we have all the pieces we need to execute the proper verification. Now with our powers combined, we're ready to verify the particular document. So we pulled the metadata, and that SQL query that we pulled the metadata from is going to be located right over here with the block address and document ID. Furthermore, we have the digest. The digest was basically the fingerprint. It is the encrypted journal that we also pulled, and it's right there. Now, what we need to do is basically click on verify to make sure that everything is hunky-dory and that it is located in the same place where we saved it, as well as relative to a previously saved digest. Now we play the wonderful waiting game, and voila, we have successful verification of the particular document. Some things to notice here, and for those of you acquainted with blockchain, some of these things may look familiar to you. You'll see right over here that you have the digest. The digest would be the encrypted journal that we used as the fingerprint, and that should basically be mirroring what you put right over here. We also have the proof hashes for additional verification, additional information. We have the block address. Remember that changes can be grouped together into a particular block. And then we have the block itself. The block is going to contain all of the changes made within it. And so you'll see right over here that you'll have the particular block address, the document entries, as well as what actually went into those tables with those particular changes. That concludes the verification process. Now we're on the home stretch. In Boto 3, we will perform 2 things. First, as an alternative to the console, we will pull the digest from the ledger. Second, we will send out a request to QLDB for exporting the journal to our S3 bucket. Now let's take a look at the Python code that we will use. Before getting started with the API code, you will need a Python interpreter or integrated development environment. First, we import the Bottle3 module and then import an optional datetime module to make it easier to work with some parameters of the Python API. Then, we set up a client linking to my .aws file for acquiring the credentials. Although you can code in your credentials, it is not a good practice security-wise and will leave you more exposed than a classical musician at a Limp Bizkit concert. Next, we declare the digest variable, which is linked to the API command for getDigest. This only has one parameter, which is the name of the ledger. We can then print the particular digest. Finally, we go into the journal export command. This one is incredibly loaded, so let's tackle the most important parameters. Again, the name corresponds to the ledger name. In this case, we're going to use a different ledger because it has more data, so we'll use the project walkthrough ledger. Within the S3 export configuration, we need to find the bucket that we are trying to export to, in this case, the one that we created. The prefix basically states whether we want within it a particular type of folder in order to house those particular exports. And finally, the role ARN or Amazon resource name, if you remember, corresponds to the role that we created in IAM. And this is important, that is, the bucket name in the IAM JavaScript object notation script, right over here, has to be the same as that of the bucket parameter here. Otherwise, you are going to be raising an error. Now we'll run the code line by line. We'll first import the modules and set up the client. Then we'll acquire the digest. For the purpose of this exercise, we won't print it here, but the digest will be captured by the variable digest for your own reference should you need to import it or save it for your print fingerprint. Finally, the big kahuna. We'll export the journal to our S3 bucket. We'll copy the particular script right over here to show the entire sequence. And we see that it is actually successful. Now, the big reveal. We'll take a look at what happens in our S3 bucket and the journal exports. Finally, we're back at the S3 bucket that we created. It seems empty for now. We'll click on the refresh button and see if it worked. And woohoo, it does! We can see the folder that we used in our prefix parameter exports. By clicking on it, we can see the export journal in our 2019 folder. This will be saved in the aforementioned .ion format that we talked about, and you can use it for a multitude of reasons, many of which we already talked. Thank you guys so much for watching, and most importantly for putting up with the terrible jokes, and I'll see you next time.